Bismillah, alhamdulillah, salatu wassalamu ala rasulillah alayhi wasallam. Today we will talk about some examples of diffusion. The first example we will take is, let's talk about diffusion in gases. The first experiment we will talk about that proves that diffusion is happening is the experiment for hydrogen. So, for example, if you have a beaker, right? And in this beaker, you have hydrogen gas, and this is a paper. So this is hydrogen gas, right? In the whole beaker. Okay, and then what I will do exactly, I will put another beaker over it. So this is the beaker, and I start to put another beaker over it. Abnormal beaker, okay. So I will draw another beaker here, okay. And this is my hydrogen gas, okay, right in the first one. What will happen if I remove this paper between them? I think you know the answer, right? The hydrogen gas will start to diffuse from one of the beakers to another one. So what will happen here? The hydrogen gas will start to spread between them, right? So the hydrogen will diffuse from high concentration where it started to the other parts of the tube. So it will diffuse in the whole tube. If I wanted to test for presence of hydrogen, I can test for it using light splint. If I have splint here, and you will try to test for hydrogen, you will find what? You will find when you use the two beakers, the splint will light with a pop sound in both of them. When it light with pop sound, it means it contains hydrogen gas. It means that hydrogen gas found not only in one tube, but only in two tubes. The same thing you can do it by open it, for example, from here or there. You will find a pop sound. It will light with pop sound. It means that hydrogen has diffused, right? Second experiment. If we talk about, let's see this experiment. We know that the reaction between NH3, ammonia, and HCl will form NH4Cl, right? So what will happen if I have a tube like this? And here I will put a cotton, close it with a cotton, and here I will close it also with a cotton wool, right? And this cotton wool will be sucked in NH3. And this cotton wool will be sucked in HCl. Let's try another color. HCl. Okay, right now what will happen? We will find that NH3 will start to move from right to left, from the area of high concentration to area of low concentration, which means the other parts of tube. The same as HCl, it will start to move, the particles start to move. But my question, when NHCl reacts with HCl, it will form NH4Cl cloud gas, or it could form NH4Cl crystals. So where the clouds will form exactly, or where the crystals will form? Will it form in the middle? Let's say this is the middle of tube. Will it form here in A? Will it form in B? Will it form in C? Where it will be formed? The answer, it will form here in C. Why is that? Why, if both of them is diffusing, right? This is diffused, moving, this particle is moving, and the other particles is also moving. Why it's not formed in middle? Because they are not moved by the same speed. If we are talking about the mass of NHCl, the molar mass, or the mass for shortcut, we will find that the mass of NH3 is lower than HCl. So the particles is lighter, right? And we say that diffusion is affected by the temperature and affected by the mass, right? Because the mass is smaller or lighter, NHCl is lighter, is less in mass, the particles will move faster. So it will move faster. So the particles, this is moving faster and this is moving slower, right? So they will not meet in the middle of the tube. Instead, they will be closer to HCl because particles of HCl will move slower, right? Okay. And if we replace NHCl with another particle that is heavier, what will happen? I think the crystal will form it in another place. Because when you decrease the speed, it will shift left toward the NH3. This is the second experiment. Let's talk about the example in case of liquid. If we have potassium water, this is water, and this is some potassium permanganate, okay? And you put a drop of potassium permanganate here, or the powder. It will start to dissolve. So diffusion, we can say it started to diffuse. Diffusion in liquid is the same as dissolving. So diffusion and dissolving, it is the same thing. So what will happen to this potassium permanganate? It will start to diffuse. So what will happen after a while to the color of the solution? It will start to turn purple. That is the same color of potassium permanganate. Okay. What will happen if we take a drop from here and put it in another tube? A beaker that is filled with liquid. This is water, and I put here the solution. A drop from here, I put it there. Although it will be diluted, it will be also colored with the same color. It will change, the color will be changed here. What will happen if you take a drop from here and take it here? What will happen? The color will start to change from what to what? The color will start to change from what to what? It will start to change from colorless, the color of water, into pink. Sorry, I think I write it here wrong. It is not purple, it is pink. And this proves what? This proves that when you put something, when you put material or another dye inside any water, it will start to fuse from another place to another. And in this case, we say it is solution. So potassium permanganate, we can say it is converted into liquid. It is now dissolved inside water, so it is solution. So what did we talk about today? We talk about diffusion in both gases and liquids, right? We talk about two examples in case of gas, diffusion in gases. We talk about the first example about hydrogen. The second one is about the action between NH3 and HCl. And the second example about potassium permanganate. Thank you.